Good morning, everybody. Today we are continuing topic 9, and in this lesson we're going to talk about what are some ways to prove that two triangles are congruent. And specifically, the title of the lesson is going to be SAS and SSS congruence criteria. Let's take a look at that. Well, today you're going to learn two ways to prove that two triangles are congruent. And the word congruence means they're exactly the same size, same shape. So the first way to prove that the two triangles are congruent, it's going to be something called side angle side congruence criteria. It says that if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. So in other words, if you have two triangles where you have one pair of tick marks, you have another pair of tick marks, and you have a pair of arcs and angles, a pair of angles that are congruent and they're in between the two pairs of sides, then you can conclude that these two triangles are the same size, same shape, which means they're congruent. And in symbol, it says that if triangle RST is congruent to triangle XYZ, we have to match the letters. So you see the R matches the X, the S matches the Y because there's a little arc symbol, and then the T matches the Z. So if you put R first, when you write the congruent statement, you have to write the X first because these two angles matches. You cannot match R with any other letters, but just X in this diagram. And then same thing with S. Since S has a little arc thingy, then you have to match with the letter that also had the arc thingy, which is the Y. And then since the T is next to this one tick mark, then you have to match it with the Z, which is also next to that one tick mark. So it's very important that you write these letters in order. If you put R as your first letter, you have to put X as your first letter. If you put R as your last letter, you have to put X as your last letter. Okay? So another criteria is called side congruence criteria. So instead of me reading this sentence, it's just that if you have all sides, all pairs of sides of one triangle matches another pair of another criteria is called side congruence criterion. So instead of reading this sentence, let's take a look at the diagram. So if you have all three pairs of sides, pair 1, pair 2, and pair 3 are congruent in both triangles, then you could tell that these two triangles are same shape, same size. So triangle ABC matches triangle DEF. So angle A, since it's between the one tick mark and the three tick marks, you have to match with the letter D, which is also between next to one tick mark and the three tick marks. So again, the order of the letters is very important. If you write A first, you have to write D first. If you write C first, you have to write F first. You kind of just match the tick marks that are next to these letters. So with those two criteria, let's take a look at example 1, which there are 4 little problems to tell whether the two triangles are congruent. So in example 1, I see that there are two triangles. I see that there are one pair of tick marks, which is just one tick mark only. There's another pair of tick marks with 2 tick marks. And there is an angle that are the same that is in between the tick marks, right? So we could use, first of all, are they congruent? And because of the SAS, right? SAS, we could say that they're congruent. So we're going to say yes. We're going to answer yes to this question, okay? And then it says, if so, by which criterion? Well, this is going to be SAS, side angle side. Now, to write congruent statement, you could start with any letter you want. Let's say YZX. So that is triangle YZX is congruent to, you have to match, Y matches with V, Z matches with W, and then X matches with U. Right, and I have to put the triangle sign in front of it. So triangle YZX is congruent to triangle VWU. Or you could say triangle XYZ is congruent to triangle UVW. Right, you could scramble those letters, but again, you have to match the angles. Okay? Well, let's take a look at the next example. Well, I see that there are two triangles, and I see that there's one pair of sides being the same. I see another pair of sides being the same. Now, you don't see the third side, but since they both share this side right here, don't you agree that they're congruent to itself? So this is also a pair of sides. It's just that they kind of merge into one, but you agree that they both triangles have Q and R as their vertex or as their corner. So the segment QR is shared by both triangles. So that means by default, they are congruent. This side is congruent to itself. So are they congruent? The answer is yes. Okay, and if so, by which criterion? It's going to be side, side, side. And to write a congruent statement, we're going to say PQR, triangle PQR, is congruent to triangle. Now, P matches S, Q matches R, and then R matches Q. Okay, so you have to write in this order. If you start with P, you have to match it with S. If you start with R, you have to match it with Q. Well, the next one is example 1C. Here it says that, well, there are two triangles. Now, I see that there are two pairs of congruent sides. There's one pair, there's two pairs. Now, there's also a pair of angles, but hold on. This angle, these pair of angles are not in between the sides here. It's actually next to one tick mark, okay? So this pair of angle is not in between the two pairs of sides. So this is not SAS. So if that's the case, are they congruent? The answer is no. If so, which criterion? So we're going to say not applicable just because we cannot prove that the two triangles are congruent. So for congruent statement, there's no congruent statement because they're not congruent in the first place. So as soon as you say they're not congruent, we don't have to answer these two questions. Well, the last pair of triangle in example 1 is we're given numbers now. We don't have tick marks, we're given numbers. But since you see some numbers being the same, I mean BC is 3 units long and EF is also 3 units long. Likewise, BA is 5 units long and FD is 5 units long as well. So here we have side, and we don't really have the third pair of information. So it's just a side being congruent and another pair of sides being congruent, which is not a criterion for congruence at all. So are they congruent? The answer is no. And if so, by which criterions are not applicable? And since they're not congruent, we don't have to write congruent statement. Let's take a look at the next concept. Well, in example 2, I would ask you to try it in class. So we're going to move on to example 3. In example 3, it says that given the two triangles on the right, what additional congruent statement is needed to show that triangle ACE is congruent to triangle SUM? Well, by SAS. So since it says SAS, we first need to underline that because we need to use that SAS to prove that the two triangles are congruent. Well, first of all, we see that they both have a pair of sides, so that's your S right there. And then we also have a pair of angle, which is your A. Now, to show another pair of sides being congruent and then the angle has to be in between the sides, we have to put an additional information. So in order for this angle to be in between the two sides, we're going to say, well, we need to know that segment CE is congruent to segment MU. We need that additional information. So to answer that question, we're going to say, well, what information is needed? We're going to say, well, that means segment EC must be congruent to segment MU, okay? If this information is present, then we could say that these two triangles are congruent by SAS. Let's do one more. In example 3, same information. Well, how do you prove these two triangles are the same by SSS? Well, we already have one pair of sides being congruent, which is represented with 1 tick marks. We have another pair of sides being congruent, which is represented by 2 tick marks. So to have a third pair of sides, we're just going to need that this side to be equal to this side. So therefore, we need to have segment MT is congruent to segment BD. Very easy. Now, what about SAS, right? So this time we don't need all pairs of sides being congruent. We just need 2 pairs of sides and 1 angle in between. So since we have 2 pairs of sides already, we need to have the angle in the middle to be congruent to the other angle in the middle, which is O and C. So we're going to say, well, that means angle O must be congruent to angle C. Well, the next thing you're going to learn is something called corresponding parts of congruent triangles are congruent. It is abbreviated as CPCTC. It says that if 2 triangles are congruent, then each pair of corresponding sides is congruent and each pair of corresponding angles is congruent as well. So if you could show that these two angles are exactly the same, don't you agree that that means everything that are part of it aren't going to be the same? That means this side must be equal to this side. That means, well, let's put it in a simpler way. That means all the sides are congruent, or they have the same length to its corresponding sides of the other triangle. And as well as all the three angles in one triangle must be congruent to the three angles, corresponding angles in the other triangle. Well, since you have three sides and three angles in a triangle, that means you have 6 congruent information. There's 1 pair, 2 pairs, 3 pairs, 4 pairs, 5 pairs, and 6 pairs. Well, let's take a look at the last two examples. In example 4, it says that given the two triangles and some congruencies, can you show that segment LV or side LV is congruent to segment AW or side W? Well, first, let's take a look at the tick marks. I see that there's one pair of tick marks, which indicate that these two sides are the same. Or congruent, and then we also see that there is another pair of tick marks which indicate that LU is the same length as AE, and then we also have one pair of angles in between the two sides. So we could use SAS to show that the two triangles are the same. So we're going to say using SAS we can prove that triangle LUV, let's say LUV, matches AEW. AEW. Remember, you have to match L matches A, U matches E, V matches W. Okay? And therefore, we can use CPCTC to show that these two segments, even though there's no tick marks, indicate that they're the same, but they're in fact the same because we proved that these two triangles are congruent, same size, same shape. So we're going to say segment LV is congruent to segment AW. Let's do one more. Well, same thing. You have these two triangles. First of all, can we show that they are congruent? Well, I see there's a pair of sides. There's another pair of sides. But then the angles are not in between the pair of sides. It's actually next to this two tick marks here. So we cannot prove, right? So use nothing. We cannot prove that triangle lit, right, is congruent to triangle DBE. You still have to match the letter. We cannot prove that. So we cannot use CPCTC to show that angle L is congruent to angle D because we cannot show that these two triangles are the same. We cannot. So therefore, we don't know whether any of the missing informations are going to be the same, particularly angle L and angle D, since there's no arc symbols on them. So we don't even know whether these two angles are exactly the same. Well, that's pretty much it for this lesson. The next couple minutes is to remind you how do you log on to your Pearson's homework. Thank you.
Hey everyone, so to get to your homework, first you go to my CNUSD website and then you click on the top of the page, my CNUSD, to log in. Well, you're going to type in your username and your password. Well, in this case, your student ID and your password. Then you go on to resource. I think for you guys it's resource. And then you go to a place called Pearson SAS Easy. Pearson SAS Easy. I'm not quite sure how you say that word, but it's Pearson Easy. Click on that. And you get to this pop-up page. And you're going to click on your class textbook. So you click on this right here. This is called Envision Integrated Mathematics 1 2009 Common Core. You click on that, a new window pop up again, and you see 3 different colors. The green color is your online textbooks. I teach from this textbooks, so if you don't have a copy, an actual copy, you could always go to here and click on the appropriate sections that we're teaching. But to find your online homework, you look at the reddish, orangish box in between, in the middle. It's called classes. So you're gonna click on here, click on classes, and depending on which period you're in, there will be new assignments here. So you're going to click on the click into the assignments, and then do your homework, and then that's it. Well, inside the homework, there are problems for you to work on, which allow you 3 attempts before they give you the final answer. So for example, for this problem, if you accidentally got a wrong answer, it'll tell you keep trying. Then you type in another answer, and if it's wrong, then it'll give you one more chance. And the third time that you got it wrong, it'll tell you the answer right away. So but you could always get help by viewing an example on this part of the feature. So it'll tell you what to do step by step, step by step, step by step until the final answer. So you could always refer to the question, help view an example, or you could use help me to solve this to actually work it step by step. So there will be more answer boxes for you to fill in, but at least it will help you on your learning. Now, for this problem, what do you do when you get it wrong, right? So to get a point or to get scores on that homework, then you click on similar questions and you keep practicing until you get it right. So if I were to click on similar questions, you notice that the questions changed. It's different from the previous one. So let's say this time you got it right. Let's say x is equal to 5, right? Well, if you got it right, it will tell you well done, okay, and then you move on to the next problem. So you click on next to move on to the next problem, like this. And once you finish all the problem, I believe the next thing is for you to make sure that you answer all the questions. If there's anything that is not answered, make sure that you go back and look at it like this, right? So this is not answered. But let's say assume that if you finish your all of the questions on your homework, then you go to the bottom, I believe. Oh, actually, this button right here says submit my work. So you click on it and then boom, I only got 3% just because I only answered one question correct, the rest I did not answer. So in order for you to get at least 80% or any good scores, make sure that you answer every single question and it's correct, not incorrect, for you to get as many points as possible on your homework. If you have any questions, please contact me.